Okay, we are going to make this a little bigger so that we can see it. Hopefully it will. All right, we're going to work with this one. And last week with the other ones, it was just a fraction on this side. So this adds the steps further that you need to remember, which is making this an improper fraction. So it's got to be top heavy. So I'm going to do the 7 times 2, which is 14, plus the 1. It's like I took that 7 and I cut it into the pieces. So 7 times 2 means I have 14 halves to make the 7, plus 1. So I have 15 halves divided by 5/8. Now, 15 halves is the same as 7 1/2. But now that I have this, I can do the keep change flip and turn it into 15 over 2 times flip is 8 over 5. Now, this is a little trick that some students do, that when you cross multiply, if you notice that you can reduce that, like if 8 over 2, I could reduce that, right? They're both divisible by 2. So I'm going to change those numbers, because 8 divided by 2 is 4, and 2 divided by 2 is 1. That's going to make my multiplication easier. And then I'm going to look at these two, and I'm going to see the same thing. Those are both divisible by 5. So I can do the same thing and reduce that into 1 and 3, because I divided them both by 5. Look at how much easier it is to multiply 3 times 4 versus 15 times 8. That'll mean that I end up with 12 over 1, and I'm smart enough to recognize then that 12 over 1, my answer is 12. All right, now we need to do our reflection, and we need to do our key concept statement. Now, the fact is, I do not remember the key concept statement, so I'm going to have to come up here and copy it so that you guys can copy it. There it is. So the key concept that we're working on is remembering that when we divide fractions, they need to change the operation to multiplication and then make the second fraction a reciprocal, which are cheating methods that we use that you may have learned before is the butterfly method, the cross multiplication, which technically isn't right because you need an equal, or keep change flip. So they both work. Then you'll write your reflection. You might choose your reflection as, this week I need to remember that I have to make both fractions improper fractions if needed. Now, if you don't know what that means that I can't have this 7 at the front. You can't have that whole number. So it has to be a fraction multiplied by a fraction, and those fractions have to be improper if needed. Okay, so if you need to pause, hit pause. If you don't need to pause, move on. Remember, our answer is 12. You should show your work because I showed my work. Let's see if we still have the work for you. There you go. So if you need it, there it is. All right, we are going to go to the bottom, and we are working at the bottom. Our key concept is, I need to use inverse operations to solve equations. I need to remember that the word equation means that it has an equal sign in it. I know that inverse means opposite operations. So in the case of this one, this is 4 times a equals 23. So I need to use that inverse operation of dividing by 4 for both sides. What happens on this side is I'm left with just the a, technically 1a, because 4 divided by 4 is 1. equals whatever 23 divided by 4 is. So I'm going to go off to the side, do 23 divided by 4. Well, 4 goes into 23 5 times, and I get 20. But it doesn't come out even, so now I have to continue and see if I get a decimal. So 4 goes into 30 7 times, because that's 4 times 7 is 28, which is as close as I can get. Okay? Remember that decimal point right there? So then when I subtract, I get 20. Okay, so this will come out even as A equals 5.75. What can your reflection be? Your reflection can be anything that you want it to be that it makes sense. This week I remembered I need to. In this particular problem, I'm going to put I needed to use long division to solve for A. It's a true statement. It also tells me that you know what long division is. You know how to properly use that decimal. So that is a little bit more things that mathematically make sense. That's today.